Hey guys, today's video is going to be running through some algebra and functions. It's simply going to be testing my thoughts as I go through them, mentioning any common mistakes, and hopefully this is helpful for you. So I've already done the first question. Okay, the idea for the question 1 is to expand and simplify the following. So I have 2 and then a set of brackets x plus 5. I am multiplying the term on the outside of my brackets by each term on the inside. So 2 times x is 2x, 2 times 5, or positive 5. Okay, the sign must go with the term. Okay, the sign in front always goes with the term, so 2 times positive 5 and we get positive 10. Then it can look a little bit different if we have 2 sets of brackets, but the idea is the same. We're multiplying each term in the first set of brackets by each term in the second set of brackets. Then we're going to try and collect like terms, and then we should be done. Okay, so I'm going to do x's. X times x is x squared. X times negative 3, okay, take the signs 2. X times negative 3 is negative 3x, and then we're going to start with the 8. 8 times x, or positive 8 times x is 8x, and then positive 8 times negative 3 is negative 24. When we're looking for like terms, we're looking for things that are at the same size, x squared. There's no other x squared terms. Minus 3x plus 8x, they both have x's by themselves, so we should be able to collect those into x squared plus 5x minus 24. Sorry. It's supposed to be a minus 24. So negative 3 plus 8 is positive 5. And then there's no other constant, so we leave that. Okay, same idea continued. We're going to do, some people might remember the FOIL method, which is your firsts, outers, inners, lasts. This really only works when there's 2 terms for each bracket, okay, which is going to be a problem as soon as we get to part D here. So each term in this bracket to each term in the other, paying attention to the signs in front of each term. Okay, and then so those are the 4 things that I'm doing. 2x times by 3x makes 6x squared. 2 times 3 is 6, and x times x is x squared. 2x times by negative 5 is negative 10x. Negative 1 times by 3x is negative 3x. And negative 1 times by negative 5 is positive 5. Alright. So any like terms, collect them. This and this is a like term, so negative 10x takes 3x is negative 13x. And then we're done. Alright, this one's a little bit trickier, quite a few terms. I didn't intend to make this as difficult as it actually is. Alright, there was supposed to be a difference in 2 squares, but it's not really important now. I'm multiplying each term outside or in one set of brackets by each term into the other. I'm going to do this one bracket or pairs of brackets at a time. I'm going to do the 2 last because I think it's easier to work with smaller numbers if I'm just multiplying everything by 2 straight away. It's just going to make it that tiny bit harder. Alright, so I'm going to start with these 2 brackets. So 2x times by 3x, and this is going to still a 2 out the front because that hasn't changed, but I'm expanding these 2 brackets to become this next set. So 2x times by 3x is 6x squared. Right. 2x times by negative 1 is negative 2x. Still got to pay attention to the signs in front of each of these terms. And then positive 1 times by 3x is plus 3x. Positive 1 times by negative 1 is negative 1. And I haven't done anything with this other bracket out on the right hand side. Okay. I can simplify this, so I'm going to do that first. Negative 2x plus 3x is positive x. Okay, we don't bother to write the ones as coefficients in algebra. It's just not important. Okay, if there's more than one, then we would, but if there's just one, no need. Okay, it's there. If it was 0, then it wouldn't be. And I've just taken like terms together so that it's a little bit easier on my next step. So then I'm going to be multiplying 6x squared by each term here, x by each term here, and then negative 1 by each term here. I'm going to get quite a bit here. 6x squared times 3x. Okay, it's going to be a little hard to see on here. And then I'm doing the negative 1 as well. So each of those, pay attention to the sign as always. Okay, 6x squared times by 3x. 6 times 3 is 18, and x squared by x is x cubed. Alright, 6x squared plus times by positive 5 is 6 times 5 is 30, and it's positive, so positive 30 x squared. Keep going. X times 3x is 3x squared. X times positive 5 is plus 5x. Negative 3x is next. Negative 1, 3x. Negative 1 and 5 is negative 5. I'm going to collect like terms, then I'm going to multiply each thing by 2 to expand the whole thing. Okay? There's my x squared terms, there's my x terms, and I've got a constant out the side. So 18x cubed, no other x cubes. 30 plus 3x squared makes positive 33x squared. Positive 5, negative 3x makes positive 2x. Take 5. And then, oops, what have I done? Scrap times 2, I've already done that part. 2 times 18 is 36, plus 66x squared, plus 4x, take 10, and now it is completely expanded. Takes a few steps. Once you get more used to it, you can start to simplify as you're doing the steps, because usually those terms land next to one another, x squared and x squared. But for now, that's how we do it. Every term in one set of bracket multiplied by every term in the other, collect like terms. Okay. Question 2, completely factorize the following showing all steps. Now, if we are factorizing, we're going to have two types of problems, I guess, just when we're removing a common factor or when we have the quadratics. So these first two is just going to be removing factors to each of these. These next two are going to be kind of like quadratics, and we need to take them out in a slightly different way. Anyways, so any common terms, common numbers or common factors to 4x squared and plus 10. So when I'm looking for factors, I'm looking for numbers that can divide both of these numbers without any kind of remainder. Okay. So let's look at the 4 and 10 first. 4 and 10, they can both be divided by 2. 2 is the largest number we can do. So I'm going to bring 2 out the front. X squared and x both can be divided by x, so I'll bring an x out the front, and then I want to actually complete that division. If I've divided 4x squared by 2x, okay, I'll show this on the side, then 4 divided by 2 is 2. X squared divided by x, it's going to get rid of the squared, because remember x squared is x times x. X times x divided by x just leaves 1x. Maybe it'd be easier to show you that. Now it looks like 3x's. Crap. There we go. 4x times by x makes 4x squared. That x is going to cancel out with one of them, just leaving 1x. Alright. 10x divided by 2x, x divided by x is just 1, 10 divided by 2 is 5, and we should be able to expand both of this bracket that we've factorized back to the same thing. So 2x times by 2x is definitely 4x squared, and 2x times by positive 5 is definitely 10x. So we can work both forwards and backwards, which is the idea of factorizing. Let's try part B. So numbers that can divide all three terms here. Let's start with the coefficients here, 18, 12, and negative 30. Okay, we can just think about it as 30 for now. 6 would be the largest one that I can think of. Okay, so I'm going to have a 6 out the front. Let's look at my A terms. Is there an A common to each of them? Yes, the highest power being 1. Okay, so I can divide each of these by A. With the next one, I've got b to the power of 4, b squared, and b cubed. Alright. Each of these terms can be divided by, looks like b squared is the highest number that I can, or power I can bring out there. So now I'm dividing each of these terms by 6, a, b squared. 18 divided by 6 is 3, a divided by a is 1, b squared divided by, b to the power of 4 times divided by b squared is b squared. Plus, we haven't taken any positives or we haven't taken any minuses out, so the sign should stay the same. 12 divided by 6 is 2, a cubed divided by a is a squared, b squared divided by b squared is just 1. Take 30 divided by 6 is 5, a to the power of 5 divided by a is a to the power of 4, b cubed divided by b squared leaves just b. And just a quick recap on what I tried to show up here. If I have something like a cubed, in fact, let's do b to the power of 4 divided by b squared. This would be b times b times b times b over b times b. 1 of each cancels, leaving just b times b or b squared up the top here. Okay, which is why I've gotten the b squared first. B to the power of 4 divided by b squared is b squared. Alright, moving on, we have quadratic here. Okay, you can tell it's a quadratic because it's got an x squared term. So there's two types of quadratics that you're going to be solving. One has quadratics, when you're solving them, you need them to look like this. Ax squared plus bx plus c is equal to 0. Okay. These coefficients a, b, and c can change, positive, negative, 0 sometimes. Alright. But it has to be equal to 0 when we're actually trying to solve them. Alright. This one we're just trying to factorize, so there's nothing to solve just yet. We're just trying to split it up into two sets of brackets, which we'll show in a second. Okay, but that's what a quadratic looks like. So with this one here, we're going to have two situations. one where a is equal to 1 and the other one when a is not equal to 1. Okay, so two situations when solving or factorizing quadratics. A is not equal to 1, meaning the number in front of x squared is not 1. Gets a little bit harder. I like to use a table. I might show you a second way just in case you don't like the table, but here's how it goes for me. Okay. Firstly, put my x squared term up top, then my constant below it. Okay. Doesn't necessarily need that plus yet, it just needs to be 8, so I'll pause on that for now. 3x squared, 8, and then the middle term, negative 10x. So when we find factors of 3x squared, which has to be, because 3 is prime, 3x and x. 3 is prime, so I can't split it up any other way. I need factors of 8, so I've done factors of 3x squared, 3x and x. Now I need factors of 8, which can be 1 and 8, or 2 and 4. And when I multiply down, I'm going to get two terms. And when I add them together, hopefully I get negative 10. Or if I can factorize this, then I should get negative 10 rather. So factors of 8, and we can make mistakes with this. So if I put it as, I'm trying to get close to 10, so I don't want to put 8 here because 3 times 8 is 24. 8 might work here, but I suspect that 2 and 4 is going to go together a bit better. Let's try this. 2 and 4 in that order. I can swap them around if I choose to. If it doesn't work, okay, order does matter here. 3x times by 2 makes 6x. 4x times x times by 4 is 4x. Alright. And this only works when both of them are negative. Okay? Negative 6x, take 4x, gives you negative 10. So these minuses have got to go somewhere up here in order to multiply them together. So negative 2 and negative 4. 3x times by negative 2 is negative 6x. X times by negative 4 is negative 4x, and we get negative 10x. I was actually intending to get that wrong to begin with, but it seems to have worked out despite my efforts. So we have our answer, but we're going to join them up in crosses in two sets of brackets. So diagonally they're going to go together. I have 3x, take 4, and x, take 2. And when I multiply these out, then I should get my quadratic here. If your first two numbers don't work, you can try something else. I'm going to show an alternate way to solve the a is not equal to 1 quadratics. Okay, so I have, let me just make sure I've got this problem right, 3x squared, take 10x, add 8. If you're happy with the table, skip ahead. If you'd like to see the other way, stick around. So what we're doing is we're going to be looking for factors of AC. AC is a number. Remember that my quadratics look like ax squared plus bx plus c. So a is 3, c is 8, positive 8. Okay, factors of AC that add to get b. So in this case, AC is 3 times 8, which is 24, and I need factors of 24 that gets you to negative 10. So 24 is, let's say 1 and 24, 2 and 12, 4 and 6, and, sorry, 3 and 8 is the other one. So we're looking for a difference of 10. 2 and 12 could work, but it would have to be positive 12 take 2, oh sorry, negative 12 plus 2, and positive and negative would not get you a positive number, so they both need to be positive or they both need to be negative. In this case, 4 and 6 have, I guess difference of 10 is not quite right, but we can make 10 by putting these two numbers together. Negative 4 and negative 6 gives you negative 10. Okay, I'll write that. Try that again. These two get you negative 10, which is your b. Okay, we need it to be b for this to actually work. So now I'm going to take these two numbers, negative 4 and negative 6, and I'm going to split up my b term into those two. So 3x squared, take, say, 4x, take 6x plus 8. So notice that negative 4 and negative 6 still go together to get you negative 10. So I haven't changed the quadratic itself, I've just made it look a little bit different. So that when I factorize in pairs, then we should see something emerge. So I'm going to bring out a common factor for these first two terms. 3 and 4 don't have any factors, but x squared and x do. Common factor of x. 3x take 4. 6x and 8. No x is common to them, but 8 and 6 can both be divided by 2. And because this negative 6 is here when I do this, I'm taking negative 2. I'm dividing each of these terms because the sign in front of the number always comes with it. Dividing each of these terms by negative 2. Negative 6 divided by negative 2 is 3, with an x next to it. 8 divided by negative 2 is negative 4. Now, you might recognize that those two terms, or that bracket, is the same for both of these numbers. So I can actually bring that out as a common factor. Bring the 3x, take 4 out the front, leaving just x and negative 2 left. Okay, and you'll notice that it's the same solution that I had before. Alright. And yeah, that's the other way of solving your quadratics when a is not equal to 1. Okay, you need to split up your b term, looking for factors of a, c multiplied together to get your b term. Okay, personally I like the table, but it is up to you. Let's power on ahead. Okay, I'm going to do something similar to what I've just done on that page there. Okay, and I'm going to split my thing here into two sections. I'm going to factorize terms in the first part. Common factors of 3x and 15 is just 3, leaving just x, take 5. Same situation here. If I have a negative, common factors of negative ax and positive 5a, I have a negative here that applies to both terms in the bracket. So I've got to divide Negative ax by negative a leaves just positive x. Negative divided by negative is a positive. But positive 5 divided by negative a is negative 5. And that's where people are going to make their mistakes. That negative could be there, but they haven't applied that or factorized that out properly from the positive 5. And so a lot of people write that as positive 5, and that's not going to get you to where you need to go. So, same situation as the previous example. X take 5 is common to both of these. So I'm going to take that out as a common factor, bring it out the front, leaving me to just 3, take a on the other side. Okay, that is page 1. Question 3. Yeah, that's better. Solve the following equations using your algebra skills. Okay, so if we're trying to solve our algebra, we need to isolate x, so we need it on one side by itself. Nothing can be added, nothing can be multiplied. Okay, just by itself, isolated. Most people would tend to, so part A, most people would expect to expand this bracket, and it would get you to the right solution, but we don't need to, okay? Because 2 is multiplying this whole thing, I can just divide by both sides by 2. So with your algebra, you're following your BIMDAS rules, but you want to undo what comes last, generally speaking. So with your BIMDAS, you have to solve what's inside the brackets first, then multiply by 2. So to undo it in the proper order, we have to undo the multiplying by 2, which means we divide both sides by 2. Whatever you do to one side, you do to the other. Otherwise, both sides aren't balanced, and then you've got an issue. Okay, you've got to balance both sides. So 2 divided by 2, 2 divided by 2 is just 1, and 10 divided by 2 is 5, so I've got x plus 4 is equal to 5. Plus 4 is coming last, addition, no timesing, so it's just whatever undoes positive 4 take 5. 4 take 5 is just 1. Those two cancel. Alright. Part B, 4x plus 9 is equal to negative 2x plus 6. With this, we have x's in 2 places. We need to make sure that it's in one place. Okay, so how do I get this negative 2x on the other side? How do I move it? As people like to say, okay, but we need to do the opposite. So you can't just bring the negative 2x to this side. You have to undo the negative 2x on this side. So what is the opposite of negative 2x? It's positive 2x. Alright, negative 2x and positive 2x are going to cancel each other out, but whatever I do to one side, I do to the other. So I'm plussing 2x to this side. 4x plus 2x makes 6x. 6x plus 9 is equal to 6. Okay. Addition's coming last, so I need to undo that first. Opposite of adding 9 is taking 9. Got to do that to both sides. I have 6x is equal to 6 take 9 is negative 3. Taking away a larger number than what we have. It's got to go into negative. Opposite of timesing by 6 is dividing by 6. So we have x is equal to negative 3 on 6. And if you remember your fractions, we can simplify to negative a half. Okay, both the top and bottom of my fraction has a common factor of 3, so I can divide both of these numbers by 3 and get to negative half. Okay. Part C, 4x over x plus 5 is equal to 3. I want to get rid of the fraction first. So I'm going to have to multiply by the opposite of that denominator. Okay, so it's 4x divided by x plus 5, and x plus 5 is in a set of brackets. Okay, you've got to solve the top of your fraction and the bottom of your fraction first. So it's like they're in brackets. Top and bottom, they're always in brackets. Okay, so I'm timesing by x plus 5 on both sides. Times by, and you know what, I'll just do it on the side. That is the step that I'm taking. Times by x plus 5 on both sides to keep it balanced, which would leave me times by x plus 5 divided by x plus 5 is just 1, so it leaves me 4x, but I've got 3 times x plus 5 on this side. X is in 2 locations, and it's also tied up inside of a bracket, so we need to get it out of there. 4x is equal to, multiply both terms, just like we did in question 1. Alright, 3x plus 15, 4x is equal to 3x plus 15. We need to move the x's to one side. Alright, move, remember you need to undo the positive 3x by doing take 3x. Don't just take that 3x and say, well, now it's 7x. Again, it's not right. You're not keeping both sides balanced. Okay. So the positive 3x, take 3x, cancels, we get x is equal to 15. 4x, take 3x, leaves you with just 1x. Alright. Part D. This one's a little bit trickier. We have kind of complicated fraction. Now, we don't like to work with these fractions in algebra. Fractions can be useful, just not in this setting. So I need to try and get rid of these denominators. So I need to do the opposite. Okay. If I am timesing by 3, for example, to get rid of this, I have to do it to each term. Okay, because I'm timesing all of one side by 3. So it would look something like that. Okay, I've timesed, maybe you'd prefer it the other way around. Times both sides by 3. I've got to do all of the left hand side times by 3 and all of the right hand side times by 3, which is a little bit easier. And that's going to cancel out this fraction. If I was going to cancel out this denominator, this fraction, I need to multiply by 2, divide by 2, times by 2. So I'm going to times both sides by 2 as well. So essentially I'm just multiplying both left hand side and the right hand side by 6. Okay? But only some of these fractions are going to cancel out. 3 is going to cancel out with 3, which still leaves me with 2 lots of x plus 2 here. Alright, because I've done 3 times 2 times x plus 2, but the 3 and times by 3 divided by 3 are going to cancel, leaving just the 2. Similar thing happens with this side. I'm taking, okay, 2 times 2 is going to cancel. No, sorry, 2 times 2 divided by 2 is going to cancel, leaving me with just 3. So I'm taking 3 lots of x, take 5. And that is equal to 12. X's are in 2 locations. There's no easier way, so I need to expand. 2x plus 4, take 3x, and here's where one of your mistakes comes up. If you're multiplying that term, you need to make sure you consider the sign, and the sign inside that bracket is negative 3 times by negative 5 gives me positive 15 to 12. So I'm going to run out of room a little bit before I've actually got there. Collect my like terms. 2x take 3x leaves me negative x plus 4 plus 15. Okay, it gives me plus 19. This is equal to 12. Okay. I don't like this negative x, so maybe I can plus both sides with x and bring it on to this side as a positive number, or we can just times by -1 at the end. Let's do that. Negative x, add 19, the opposite of add 19 is take 19 from both sides, and I get negative x is equal to -7. Alright. To get rid of the negative, I can times or divide by -1. Okay, so this would just leave me negative times negative is a positive. Negative is going to cancel on both sides. X is equal to 7. So if I put 7 back into my original equation, then I should get the right-hand side here. Okay, and that goes for each of these problems. If you can put your solution back into the original problem and come out with the right-hand side, then you're doing something right. Okay. Question 4, part A. We are trying to solve the following quadratics by factorizing and the null factor law. Now, in case you've forgotten, the null factor law tells me that if I have two numbers times together and they equal 0, then either A is equal to 0 or A is equal to 0. That is the idea. Okay, we can use this with our quadratics, making sure that when we have any quadratic, which is represented as this, if it is equal to 0, then we can start to solve our quadratics. If it's not equal to 0, you need to start there, which we're going to look at in part C, because this quadratic is not equal to 0. So, part A, we are going to look, we've got two numbers, this first bracket and this second bracket, and they times together to equal 0. So either x plus 4 is equal to 0, or 2 take x is equal to 0. Now once you get a little bit more used to it, you'll be able to just essentially be like, well, the opposite of positive 4 is negative 4, and so you would get two solutions. You could solve these. The opposite of plus 4 is take 4 on both sides, leave you with x is equal to -4. On this case, we're going to have to bring x onto the other side, and we get 2 is equal to x. Let's kind of keep doing that. Not good. Still recording. We're happy. Alright. So we had two solutions, -4 and +2. Now, if they're quadratics, sometimes you need to factorize. We spoke about a case in question 2c where a is not equal to 1. Okay, kind of like in part D. These ones, a is equal to 1. There's no number in front of the x squared term, so we're pretty happy this is the simpler case. In part B, we're looking for numbers that multiply to get to -12 and that add together to get 4. So we're looking for factors of 12 to begin with. 1, 12, 2, 6, 3, 4. And they need to add together somehow to get +4. So +4 times together to get -12. I've just written out the factors of 12 now, and I need to think about, how do I get +4? Well, if I had +6 and -2, +6 take 2 is +4, and also, because I have a negative and a positive, I get a negative. So if you have a negative here, one of your numbers has to be a negative. If it's a positive here, then it's the larger of those two numbers that has to be positive. If it's a negative here, then the larger one would be negative. Okay, it's a bit to unpack there, but hopefully this is more revision. So we have two sets of brackets, both starting with x, and we're going to take out two numbers here. We have -2, +6, and then we're done. Done with the factorizing anyway. We still need to actually solve. How do I make this equal to 0? Well, x either has to be 2 take 2 is 0, so x has to be 2, and the opposite of +6 is -6. If I put a -6 in there, -6 plus 6, still 0, 0 times 0 is 0, solution, we're happy. Alright, part C, x squared plus 20 is equal to 29. As I mentioned a little bit earlier, as I was talking about part A, we need our quadratics equal to 0, otherwise we're going to have a bit more difficulty. So let's start there. How do I make 29 0? Well, I take 29. Got to keep it balanced though, both sides. Whatever I do to one side, do to the other. They're going to cancel. 20 take 29 is just 9, or -9 rather, and that's equal to 0. We've got a quadratic, x squared, whatever else, and that's equal to 0. So, this one looks a little bit weird, but we're looking for factors of -9 that add together to give you 0. Some of you might know this pretty quick. 1 and 9, 3 and 3, and because it's a -9, one of these numbers has to be negative. +3, take 3, okay, and that's 0. Add 3, take 3 is 0. Remember that there is in here we have 0x, okay, x squared plus 0x, but we don't show the plus 0x because there's no point. And so that's adding up to my b, factors of -9 that add together to give you 0. So we get x, add 3, take 3. We might also remember the idea of a difference of 2 squares. And that's when we have a, add b, a take b, and we get the first term squared, a squared, take the second squared, term squared. If you can recognize this pattern, difference of 2 squares, it can be pretty useful sometimes. But your standard factors of c that add to b, which you can't see here, but is 0, then you still get the same spot. Alright, we have a bigger quadratic here where a is not equal to 1. Alright, so remember, number in front of a is your a, or your coefficient of x squared is a, or the number in front of x squared is a. So I like the table, I'm going to stick with that. You can see the other method going back to 2c if you would like. I'm looking for factors of 3x squared and 5. It's going to be negative eventually, alright, but I'll think about that later. And then -14x. Okay, I'll move that across just a little bit so that I don't forget to put my minus in there. So factors of 3x squared can only be 3x and x because 3 is prime. 5 is also prime, so this is going to be slightly easier for us. We only have one pair of numbers and we can test them one or the other ways. We can put a 5 here, 1 here, or a 1 here, a 5 here. I'm trying to get to -14, and I think a 15 is going to get me a lot closer because I'm multiplying down. 3x times 5 is 15, x times 15x, sorry. X times 1 is x, and I need a negative 14, so the larger of these two numbers should be negative. Negative 15 plus x is equal to negative 14. One of these numbers has to be negative. It's easier on the negative 5 personally, I reckon. And then diagonally together. So 3x and positive 1 and x take 5. And this is still equal to 0. Goes to me for part C, I did not give a solution. X should be positive or minus 3. So anyways, part D. Still looking for solutions for x. In this part, we've got x is equal to, easier one's going to be this side here. Could be positive 5. Or, and now we've got to think about this bracket, it's going to be the negative 1. Alright, and it's going to be the opposite of times by 3, divided by 3. Okay, so if you put negative 1/3 into x here, then this bracket should equal 0. And you can double check this by solving this tiny equation here. Opposite of add 1 is take 1, divided by 3, still getting us to the same spot. So, let's try question 5. This is a bit longer. We need to make sure that we understand what the discriminant is. So I'm going to go on a little bit of a tangent here explaining what that is. Okay, when we have quadratics, we can have one solution, two solutions, or no solutions. And the discriminant is a handy bit of information that comes from our quadratic formula that tells us which is which. So let's go to the quadratic formula first. Negative b plus or minus the square root of b squared take 4ac on 2a. Okay. This part under my square root, okay, I will highlight that. The part under my square root, and that's important later, is the discriminant. Okay, so my discriminant is equal to b squared take 4ac. Now remember, this is for quadratics that are of the form so that they look like ax squared plus bx plus c is equal to 0. A in my quadratic formula here is the coefficient of x squared when this quadratic is equal to 0. B is the coefficient of x when this quadratic is equal to 0. And c is your constant at the end. Again, quadratic has to be equal to 0. Common mistake that comes up. This is about the discriminant though. B squared take 4ac. Now, depending what this number is, can tell us a bit about our quadratic. Okay, if the number under the square root, okay, if this number under the square root is a positive number, so the discriminant is greater than 0, then you have two solutions because the square root of a positive number gives you 2. It's one is the positive solution, one's the negative solution. Okay. When your discriminant is equal to 0, then you have one solution. Okay. When the number under the square root is 0, you can only have one solution because plus or minus 0 doesn't change the rest of it. Okay. Only one solution when that number is 0. Doesn't change anything. Now this one's a little bit less familiar to us. If your discriminant is less than 0, so the number under the square root is a negative number. And what you might remember is that the square root of a negative number can't be done. No real solutions. Can be done. It goes into a thing called imaginary numbers, unimportant to us at the moment, but you cannot do the square root of a negative number because two numbers that multiply together to get a negative can't happen. Okay, you can get a negative and a positive to get together or to times together to get a negative, but then they're no longer the same number, so that can't be a solution. So there are no real solutions. There are some imaginary ones. Now, the best thing about the discriminant that I think is that if your discriminant is a square number, so something like 1, 4, 9, 16, 25, etc. Or another way to say this, that the square root of your discriminant is rational. Okay, rational has its own meaning. Okay, that means it can be expressed as, my handwriting's gone a little bit. Let's try that again. Expressed as a fraction. Can be expressed as a fraction, sorry. Rational means it can be expressed as a fraction. Fraction, mostly what we're looking at here would be integers. Okay, if the square root of your discriminant is rational, usually integers, so 1, 4, 9, 16, 25, the square root of 25 is going to give you plus or minus 5 integers. Alright, this means that, where do I put this? This means that it is factorizable. Alright, I'm actually not certain that's a real word, but it can be factorized if that square root of the discriminant is rational, and that can help us to do some other things. Alright, now that we've gone through that, the discriminant is the first thing that we need to do in question 5. Use the discriminant to determine the number of solutions. So if it's positive 2, if it's equal to 0, 1, if it's less than 0, it has to be 0. And that's what we need to do first. So pay attention, all of these quadratics are equal to 0, so we don't need to change anything. But we're following this pattern, ax squared plus bx plus c is equal to 0. So for this one, a is equal to -1, b is equal to -4, and c is equal to +2. So my discriminant is b squared take 4ac, which means I'm doing -4 all squared take 4 times a times c, 16 4 squared, or -4 squared, gives me +16, take, or negative times a negative actually, sorry, negative times a negative is a positive, so positive 4 times by 2, that's actually going to be +8, and we get 24. Now, it is a positive number, so there is 2 solutions. It is not a square number, okay? You can get 16 or you can get 25. So we need to use the quadratic formula to find this solution. And I'm going to run out of room for sure. We've already worked out what's under this square root, so we don't need to work it out twice. -b, which means we've got -4 plus or minus the square root of 24 on 2a, 2 times -1. Alright, I'm just going to go to a separate bit of paper to show you the rest. We have, starting from Try that again. Negative 4 plus or minus the square root of 24 on 2 times negative 1. Alright. Negative makes a positive. 4 plus square root of 24 over negative 2. Negative can just come out the front, and we'll just do divided by 2 there. Alright. The surds are a little bit different. Okay, we can simplify this further if we understand our surds a bit more. So there's a lot to unpack in question 5, but if we can express 24 as the product of two numbers, so for example 24 has factors 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, if any of these numbers is a square number, okay, 4 is a square number, we can express square root of 24 as square root of 4 times 6, and then we can split this up. Square root of 4 times the square root of 6. Okay, the reason that we're picking a square number is because the square root of 4 is just 2. So the square root of 24 is 2 root 6. Better written like this. So that's kind of separate to our problem here, but we can use this as plus or minus 2 root 6 on 2. If both of these terms can be divided by 2, then we can cancel. Alright, 2, 1, 1. Alright, I can't just divide one of those terms because what I'm looking at is negative 4 on 2 plus or minus 2 root 6 on 2. That 2's got to divide or be split amongst both of those terms. So I get negative 2 plus or minus square root of 6. Alright. X is equal to negative 2 plus or minus the square root of 6. Alright, I understand it's a long video. Part B. Discriminant first. B squared take 4ac. A is 3, B is negative 4, C is 2. I'm way too close to that video on camera. So, negative 4 all squared, take 4 times 3 times 2. Okay, so we get 16, take 4 times 3 is 12, 12 times 2 is 24. There's no other negatives to cancel out with this one, so we've got 16, take 24, which is negative 8, less than 0, no real solutions. And we're done. Alright, last one. For 5c, b squared, take 4ac. Alright, so we've got b is equal to negative 10, which is all squared, take 4 times a times 25, which is equal to 100, take, there's no negatives here, so it's going to remain a take, 4 times 25 is 100, 0. If it's equal to 0, then we have one solution. Okay? It also means that this is factorizable, but because it is factorizable, that might be the easiest solution, but if you are stuck with that, the quadratic formula would still work. With this, we're looking for factors of positive 25 that add together to get negative 10. Okay, so two numbers that multiply to get 25 to get negative 10. Well, negative 5 and negative 5 times together to get positive 25 and add together to negative 10. and this is equal to 0, so x is equal to positive 5. There are two solutions here, but they're the same solution. Okay, you might also remember that this is a perfect square and can be written like that. Perfect squares, in case we've forgotten, I will quickly mention, is when we've got a plus b or a minus b all squared. Then when we expand it, we get a squared plus 2ab plus b squared. If that was a minus, then that would also be a minus. Okay, so you could represent it like that if you wanted to. Cool. Last question. We've just gone over the hour. This one we're doing direct proportion. Question 6. The amount of kinetic energy an object has is directly proportional, okay, to the square of its velocity. Energy is proportional to the square of its velocity, which means that energy is equal to some multiple of v squared. Okay, I'm trying not to use the k because I want to use that as my constant here. Now, let's look at the information. An object has kinetic energy of 250 joules with a velocity of 5 meters squared. What will the velocity be if it has an energy of 640 joules? Well, the first thing that we need to do is find this constant k, and we've been told that my energy is 250 when v is 5. v is squared. Okay, so 250 is equal to 25 lots of k. Divide both sides by 25. K is equal to 10. And then we can use this information for the next part. What will the velocity be if it has an energy of 640 joules? So 640 is 10 lots of v squared. Okay, we've just substituted from here, and we know what k is, and we've also placed energy in. So divide both sides by 10 because we're trying to get the v by itself or isolated. We get 64 is equal to v squared. So v is equal to the square root of 64. V is equal to plus and minus a. Anytime you take the square root, two solutions, positive solution and the negative solution. Alright, that's all for the non-calc section. I hope you found this useful, and you'll find the rest of this section, or the next section, the calc section, in the next video. Thanks for watching.